Okay, this is Conditional Probability by Professor Ribas. What is conditional probability? Well, when you know or are given one condition has happened and you're interested in seeing what the probability of the other condition is. Let's look at a couple of examples. You're a medical company testing a new medicine. So you know some of your patients have taken medicine A and you want to see what the probability is they have a heart attack when you know they're on that medicine. You might want to compare that to the probability they have a heart attack when they're not on the medicine. So we would write that. Probability of heart attack given they're taking medicine A. This vertical bar means given. You know that everything after that vertical bar has happened. So you can write it either way as a sentence, or you could turn it into a slightly shorter hand notation. Some other things you might look at are probability somebody graduates if you know they passed English 101. A college administrator might be interested in this. They might say, well, if we can get students through English 101, they're much more likely to graduate. The probability they graduate when they pass English 101 is this. So we should have an emphasis on these students to get them through 101. Might be very important in decisions the college was doing to try and set up a more efficient protocol for its students. So let's try an example. We'll say a big college has 5,000 freshmen. By the end of their freshman year, 60% have passed English 101, 55% have passed Math 142, and 41% have passed both. How many have passed neither English 101? So these are some questions you might be asked. Enrique passed Math 142. What is the probability he passed English 101? And Sharoom did not pass English 101. What is the probability she also did not pass Math 142? You might also be asked some questions like, are these correlated or are they independent? And we'll get to those in just a minute. Now, if you've already seen some of the other videos on conditional probability, I recommend that you stop or pause this video now and give this your best shot. That's the most effective way to learn, is when you try and see what you know already. And you might have a different way of doing this, which is fine. I'm going to show you my way, but there are many ways to do this kind of problem. I think mine is pretty easy to see, so I'm kind of happy with it for me, but you can compare it to your approach as well. So stop the video, follow my advice on this, give this a try, and then come back and compare your answer to my work. So my way is using a Venn diagram. So we have 5,000 freshmen. By the end of their freshman year, 60% have passed English 101, repeating the problem here. So let's look at the English 101 circle. I put 41% in the intersection of English 101 and Math 142 because we know that they've passed both. But I only put 19% here, and I want to address that. A frequent problem I see is for students to write 55% here, 60% over here, or vice versa, 60% here and 55% there, and then 41 here, and then just all craziness. You're way past 100% at that point. It makes no sense. There's only 100% of students, or 1 if you're doing this in probability. Don't really care if you use decimals, 0.14 or 14%. It's the same thing. So the proper way to do it is put the intersection first and then put the proper numbers here. These two add to 55% to give us what should pass math. And these two add to 60% to give us what should pass English. Because these 41% are in both circles. They are already counted. Doing it that way, we're short 26%. So that's what goes out here. And the box is all students at the school. If we had different questions where we needed numbers, we could multiply all these percents by numbers, and I'd have 26% times 5,000 to have a number of students here. So we could look at this a lot of different ways to answer our questions, and they're all correct, as long as you've handled the intersection and these numbers properly. So how many have passed neither English 101 nor Math 142? The answer was 26%, or 0.26. I don't personally care which way you write it, but your Canvas homework certainly will. So unless it says percent in the question, use the probability, the decimal version of the answer. Next question. Enrique passed Math 142. What is the probability he also passed English 101? Now let's review the way we write this in probability. Probability of passing English 101 given you know he passed Math 142. And you know that because you were told Enrique did pass Math 142. So here's the right way to look at these, and you can do these with trees or do them thinking other ways, but here's how I think about it. We know he passed Math 142. So out of all the 100% of students at the school, we don't have all 100% anymore. We only have the ones that passed Math 142. If I look down here, that's the 41% in the middle and the 14% that exclusively passed 142 with nothing else. So it is 55%, the number you were given, but I like to break it into these pieces and put it on the bottom of the fraction. And that's where I would start this. You're seeing the answer all put together because I'm not real good at typing while talking and running the recorder. So 41 plus 14% is 55%, but I like to break it into the components, and I do this first. Now I see what would answer the question. I put that on top. Except for typing purposes, I would have drawn it this way and put the number up here. So, well, I need the people who passed 101, passed English 101, out of the ones who passed 142. So I'm only taking from this select group who passed 142, the 41 and the 14. Which of those passed English 101? The 41%. So I put that on top of the fraction and I evaluate. I see this number show up a lot. Hey, they passed English 1, it's true, but they did not pass 142, so they're not in this problem. They're not in the restricted world of people who passed Math 142. So the correct answer is 41% divided by those two for 74%. Now notice this. Probability passed English 101 has jumped up to almost 75%. When it started, if we knew nothing else about it, it was at 60%. So if you knew nothing about Enrique and someone said, what's the probability he passed English 101? It'd be 60%. Now that you know he passed Math 142, it has jumped up. This is showing a positive correlation. Passing English and passing math, in this case, are positively correlated. If you pass one, you're more likely to pass the other. Now you can't just reason that out. I could change the numbers in this problem very easily and make there have no correlation, in which case they're independent. They don't influence each other in any way. And in that case, this would have come out to 60%. There'd be no change at all. Or I could make it less. I could make it where if he passes math, he's not going to pass English as likely. So it could drop here and you'd get a lower number. So that it's always determined on the numbers. And of course, they're not independent. They happen together. There is an intersection. Okay, and the last question. Shireen did not pass English 101. What was the probability she also didn't pass 142? So probably failed for 142 given that you failed English 101. Well, these two numbers are inside English 101. I want the people who are outside of English 101. So everyone outside of this circle is the 14% over here and the 26% here. They're the ones who did not pass English 101. Out of those two numbers or groups of people, which ones also did not pass math? And that's the 26%. So we get 65% or 0.65 when we do the math. We notice the correlation as well in the not world. If you don't pass one, if you fail one, you're more likely to fail the other as well. And once again, that always comes down to the numbers invented. So hopefully that has made a simple and succinct way of doing conditional probability. Thank you for watching this video and good luck on your homework.